Welcome back to our Azure Container App series. Previously, we covered the basics of ACA, what it is, why it is useful. In this video, we're going to go under the hood to explore ACA's architecture, including the control plane, data plane, environments, revisions, and more. By the end, you'll have a solid grasp on how ACA handles your container workloads from deployment all the way to production. At a high level, ACA is split into two main parts: the control plane and the data plane. We'll start with the control plane, which has two main jobs. The first is configuration management. When you deploy or update a container app, you interact with the control plane. It stores your app's configuration, environment variables, secrets, and network settings. Second is the deployment logic. The control plane receives your commands such as create a new revision or change auto-scaling rules, and orchestrates these changes across the system. Moving on to data plane, this is where containers live. The data plane hosts the actual running containers. This is where your code executes and where user traffic or event triggers are directed. It's also responsible for routing requests to the correct container instance, enforcing auto-scaling, and applying any network or security policies. I've put a diagram on the screen to hopefully help you understand the difference between both of these planes. The separation ensures that you can define how your app should run in the control plane, while the data plane handles actual execution and scales dynamically based on your instructions. An ACA environment is also a crucial concept. Think of it as a logical boundary or a mini cluster within which you can deploy one or more container apps. We will break down the ACA environment into three main components: isolation and networking, resource sharing, and scopes and limits. Starting with isolation and networking, you can configure your environment to either use public endpoints or be placed in a private network using Azure Virtual Networks. This allows for scenarios where multiple container apps talk to each other internally without exposing all services publicly. The second is resource sharing. All container apps in the same environment can share configuration settings, secrets, and monitoring settings. This makes it easy to manage multi-service solutions where apps need to communicate frequently or rely on common resources. And the third is scopes and limits. Each environment belongs to a specific resource group and region. Environments have certain quotas, for instance, how many container apps can be deployed, concurrent limits, etc. So plan ahead based on your workload. In essence, the ACA environment acts as a unified context for your containerized microservices, enabling secure and efficient communication. One of ACA's most powerful features is its revision management system. Whenever you update a container app, changing an image version, environment variables, or scaling rules, ACA creates a new revision while preserving the old one. There are a few different features, and we will cover them briefly now. The first is immutable snapshots. Each revision is essentially a snapshot of your app's configuration at a point in time, including the container image reference and any scaling or networking parameters. Another is rollback friendly. If your latest deployment fails or introduces a bug, you can quickly roll back to a previous revision without completely redeploying the old version. There's also gradual rollouts. You can assign a percentage of incoming traffic to your new revision and keep the rest on the old revision. This helps you do canary testing or A/B testing to validate new features before fully rolling them out. Blue-green deployments keep an entire old revision live. Blue, while you spin up the new revision. Green. Only when you are ready, you switch traffic from blue to green. I'm putting a visual example on the screen. This mechanism allows safe experimentation and fast recovery in production environments. Kind of like how we touched on in the previous video, auto-scaling in ACA is powered by KEDA, which stands for Kubernetes-based event-driven auto-scaling. It provides event-driven scale-up or scale-down. KEDA monitors metrics and triggers such as CPU usage, HTTP request rates, message queue lengths, or even custom metrics from Azure Monitor. When a threshold is crossed, let's say queue length is greater than 50 messages, Keda instructs the ACA data plane to spin up more containers. Another benefit is scale to zero. If there's no incoming traffic or zero jobs in a queue, ACA can deprovision containers entirely, cutting compute costs. This is ideal for event-driven or low-traffic apps, so you don't pay for idle resources. In addition, real-time responsiveness is a great benefit. Keda continuously evaluates and triggers and scales your container apps in near real time. This helps make sure and maintain performance during traffic surges, but also save money during quiet periods. By leveraging Keda, ACA combines the flexibility of containers with a serverless pay-for-use model, making it an excellent choice for bursty or event-driven workloads. To effectively manage your apps, you need observability tools. ACA provides some great built-in integrations. You have access to Azure Monitor and log analytics. You can track CPU usage, memory consumption, request counts, etc. You can also see container logs, revision changes, scale events all in one place. In addition, any alerts, for instance, configuration alerts, send an email if CPU usage exceeds 80% for 5 minutes. You can configure different notifications depending on things which are important for your application needs. The second is application insights. You can have distributed tracing. If you're running microservices across multiple container apps, you can use application insights to trace requests end to end, which is invaluable for diagnosing bottlenecks. Dependency maps help visualize calls between services, databases, or external APIs to understand system performance. You'll also have access to debugging tools like live logs and shell access. In some cases, you can even attach to live logs in the Azure portal or via CLI, helping you quickly see real-time output and diagnose issues. All these tools allow you to monitor performance, detect anomalies, and maintain high reliability for your containerized applications. Beyond the basics, there are a few more areas to keep in mind. Networking and security are of utmost importance. Integrate ACA with Azure Virtual Networks for private communications. Use Azure private endpoints to ensure traffic always stays within Azure and is not exposed to the public internet. Manage secrets with Azure Key Vault or environment variables, ensuring secure handling of credentials. If you need multi-region setups or geo-redundancy or disaster recovery, you can also create multiple ACA environments in different Azure regions and route traffic via Azure Front Door or Traffic Manager. Another thing to keep in mind is cost optimization. While ACA is pay for use, it is still important to monitor usage and adapt the best practices like scale to zero or right sizing CPU memory for each container. All right, a lot of information. Let's summarize what we've learned about ACA architecture so far. We talked first about the control plane and data plane, which provides a clear split between management and runtime. Second, we talked about the ACA environment, a logical boundary sharing configuration, network, and security for multiple container apps. Third, we talked about revisions and traffic splitting, enabling safe deployments, rollbacks, and canary releases. Fourth, we talked about autoscaling with Keda, dynamically responding to workload changes, including scaling down to zero. Fifth, we talked about observability, log analytics, Azure Monitor, and application insights to help you keep everything under control. In the upcoming videos, we'll explore hands-on demos, advanced networking, and security best practices for ACA. If you have any questions or topics you'd like us to cover, drop a comment down below. Thank you for tuning in. Don't forget to like and subscribe, hit the notification bell icon to stay updated, and we'll see you in the next video.